Auzubillahi Bismillahirrahmanirrahim. Sayyid Farhad Ali with you. In today's lecture, I'll explain you people how the latent image is converting into a visible image and how the image reader works. So for that, first we need the latent image. How we will achieve a latent image? First, we will have to take the cassette. Then we will insert the cassette in the standing cassette holder on the bucky or the cassette holder which is under the table, or we can simply put the cassette upon the table. In this image we put the cassette upon the table and we position the patient for the exposure. Okay, from here when we press the exposure button, the x-rays will come out and will goes directly and will take the information of the patient's body and will paste on the cassette. Inside the cassette there is imaging plate. After exposure to the x-rays, we will take the cassette and we will put inside the image reader. This is an image reader, and one of the technician or technologists put this cassette inside the image reader. This is now the cassette inside the image reader, but let me tell you, in this cassette, inside the cassette there is an imaging plate, as I have shown you in the previous video, the imaging plate. Okay, in this imaging plate there is information. The information came from here because previously we exposed the patient to the x-rays. The x-rays took information from the patient and paste all those information on the imaging plate. The information which is present now in this step and the imaging plate, we call those information as a latent image because we cannot see those information now. Those information which we cannot see after exposure of patient to the radiation, we call this latent image. Latent image means a hidden image we cannot see. As I told you people in the previous video that the latent image, the imaging plate, the IP, which is inside the cassette, consists of many layers, but the most important layer of the imaging plate is the PSP, the photostimulable phosphor. This is the most important layer of the imaging plate. Okay, after exposure of this cassette having inside the imaging plate, the electrons of the photostimulable phosphor, okay, electrons, normal electrons are in the ground state. Okay, when exposed, this line shows that the electrons are in the ground state. Okay, after exposure of the imaging plate to the x-rays, the electrons from the photostimulable phosphor is going to the excited state. These electrons, will all go to the excited state. Why it goes to the excited state? Because it's gain energy from where? From the exposure of the x-rays. As x-rays are the photons, the packets of energy. After passing this energy from the patient's body, taking the information from the patient's body and pasting over the imaging plate. The most important layer of the imaging plate is the photostimulable phosphor layer. The electrons from the photostimulable phosphor layer is going to the higher energy state because it's gained energy. Okay, just keep in your mind the electrons of the photostimulable phosphor are now in an excited state. Okay, and this will help you in the next slide. Okay, let me remind you again, the x-ray tube, the x-rays come out of the x-ray tube and strike with the patient, passing from the patient, and the appearance of the latent image on the imaging plate. Okay, this is the latent image. In the latent image, the electrons are in the electrons of the photostimulable phosphor are in the excited state. What's going on after the latent image? Now the main process starting, like how we will convert the latent image into a visible image which appears on the computer in the form of the digital signals. In the next step, the imaging plate are exposing to the laser light. Here the laser light which is using here are neon helium laser beam. Okay, what's the function of this laser light? Why we are exposing that latent image and to the latent image to the laser light? Because here in the latent image the electrons are in the excited state. Okay, all the electrons are in excited state. After exposure to the laser light, the electrons which are in the excited state are coming to the ground state. These all electrons are coming to the ground state, losing their energy. After losing their energy in the form of light. Okay, in the form of light, in the light which is emitting from the electrons which when it is coming to the ground state, this light is usually blue purple light. In front of this imaging plate, here is photomultiplier tube. What is the function of photomultiplier tube? The photomultiplier tube is catching the light, the blue purple light which is coming out of the imaging plate by exposing this imaging plate to the laser light. The electrons are coming to the ground state and emitting the blue purple light. The blue purple light is catching by the photomultiplier tube. This is the first function of the photomultiplier tube. Another function of the photomultiplier tube, it's converting that blue purple light into the analog signals. Okay, light into the analog signals. I will write here L into A, means light into the analog signals. So there are two functions of the photomultiplier tube. Number first is the capturing of the or receiving of the light which is coming out of the latent image, or which is coming out of the imaging plate. Another function, it is converting that light into analog signals. But we cannot see the analog signals. The computer is not getting analog signal. To display something on the computer monitor, the analog signals should be converted into the digital signal. To convert those analog signal into digital signals, we are using here amplifier, and the amplifier is the analog to digital converter. The analog to digital converter is converting the analog signal which come out of the photomultiplier tube. This analog to digital converter is converting the analog signal into digital signal, and the digital signals are then transferred to the computer, and the computer shows us those digital signal in the form of the image. So this was the whole phenomena of the conversion of the latent image into a visible image. Okay, this was the whole process. Okay, the last step. In the last step, we are exposing the imaging plate to the visible intense light. Why? Because some of the electrons of the imaging plate of the photostimulable phosphor, even after exposing to the laser light, not coming to the ground state. Okay, majority, more than 80%, or we can say more than 90% of the electrons from the photostimulable phosphor are coming to the ground state after exposure to the laser light. But the remaining electrons, or the rest of the electrons which are still in the excited state, we will expose that imaging plate to the imaginary intense light. Okay, intense light, to bring all those electrons which are in the excited state into the ground state. So 100%, or we can say all of the electrons which were in the excited state, now they all are at the ground state. Okay, when all the electrons at the ground state, means there is no information. All the information which been stored before on the imaging plate are lost. Okay, and again we can use that imaging plate for another exposure. So this was the whole process. Patient exposed, we get a latent image, then we use laser light for the conversion of that latent image into a visible light. Okay, this light is then going and trapped by or catched by the photomultiplier tube. The photomultiplier tube is converting that light into analog signal. The analog to digital converting is converting that light into that analog signal into the digital signals. Again, I will explain that phenomena here in a little more detail. After exposing the cassette to the X-rays, the imaging plate, then we are inserting that cassette into the reader. After that, the imaging plate is coming out of the cassette, and these, you can see this is a roller, this and that. The roller helps in getting the imaging plate inside the reader. Okay, when it goes inside the reader, then we use the laser light. Here is a mirror. The laser light is going and fall on the mirror first. After that, it is coming down and falling on the imaging plate, which is erasing or which is bringing down the electron which are in the excited state into a ground state, okay, by the emission of the light. Here is a photomultiplier tube. It is catching the light and converging the light into analog signal. After that, the analog signal are converting into the digital signal by the analog to digital converter, and in the last, this digital signal are displayed on the computer. Here I will show you that's practically. Okay, this is the image reader, and just keep in your mind, when this light turns green, then you will insert the cassette inside the reader. After that, when you insert the cassette inside the reader, this is white. You can see here, this is the imaging plate. The imaging plate is removed from the cassette, and I showed you in the previous slide there are some rollers. The roller is getting the imaging plate inside the reader. After that, when the imaging plate gets inside the image reader, the green light will turn to yellow. Now in this time, when the green light turns to the yellow light, that means that the image is not processing. Okay, the conversion, the laser light is on at that time, and then bringing the electron into the ground state and conversion into light, then photomultiplier tube, after that analog to digital converter, this whole process. Okay, look over here. The cassette is inside the inside the image reader. The imaging plate is removed, and through help of rollers, it goes inside the reader. Okay, after that, this is the part of the image reader. From here, the laser light is coming out. Okay, after coming out of the laser light, falling on the imaging plate, the electrons coming down to the ground state and emitting light. At the time, the light which is emitting is captured by the photomultiplier tube. After catching the light by the photomultiplier tube, it is converting into the analog signal, and after conversion into analog signal, by conversion of analog signal into digital signal by analog to digital converter, okay, ADC, the final image is displaying on the computer monitor. And this is the final image which is displayed on the computer monitor after passing through this whole process. Hope so you get enough information about the conversion of latent image into a visible image, how we will get the latent image, and how the image reader works, and how many parts of the image reader, and the whole process. Thank you so much.